This is the second video in a three-part series. In the first video, we used a lump sum to compare and contrast discounting and compounding, and we also experimented with using both formulas from a textbook and the Microsoft Excel functions that are already built into Microsoft Excel. Today, we're going to expand that to the concept of an annuity, and we're going to take a look at compounding when we deal with an annuity. We're also going to see how the annuity do formula is different from the ordinary annuity formula. As is my usual practice, off screen I went ahead and set up this spreadsheet. And what I'm going to show you today is I'm going to show you the differences between discounting and compounding when we have an annuity. An annuity is just a stream of cash flows. So in this first example, we're going to be making a payment every month of $416.67 into some type of investment. And that investment is going to grow in value, and at some point we're going to have some future sum of money sitting in that investment. So what we're going to do first is we're going to start off by calculating an ordinary annuity. And after we calculate an ordinary annuity, we're going to do the exact same thing for an annuity due. The difference between an ordinary annuity and an annuity due is the timing. An ordinary annuity has the payment happening at the end of the month on the last day. The annuity due is going to have the payment happening at the beginning of the time period, so the first day. So the formula for an ordinary annuity is straightforward. We type an equal sign and we enter the periodic cash flow. In this case, it's $416. So again, think about this version as I'm investing $416 per month to save for the future. So that's $5,000 a year spread out evenly over the month. We'll type an asterisk to multiply, and then we have an open parenthesis, and the formula gets kind of ugly. So just kind of hang with me a second. I'm going to open another parenthesis, and I'm going to type 1 plus our interest rate, right? But our interest rate is going to be our interest rate divided by our 12 months. So let's do another parenthesis and enter the interest rate, a slash to divide, and click on our 12 months. So we're going to take that 8% interest rate and basically divide it by 12 so that every period we're compounding a little bit differently. We're going to close that parenthesis. We're going to raise this to n times k. So open parentheses, n, which is 10, an asterisk to multiply, times k, and then we'll close the parenthesis. And now we want to close that, I think. Well, actually, let's try it like this. Let's subtract 1. That's the next part of the formula. And then finally, we divide by our interest rate, which is 8% divided by the 12 months. And what I want you to notice is this is just a little bit complicated. There's a lot going on in this formula. And it's important that you go through and do a little bit of work to make sure, a little diligence to make sure you have the order of operations correct. Make sure you're not accidentally entering something in wrong. So I'm going to add a couple of more parentheses here just to make sure that the order of operation is right. And I'm going to press enter and see what I get. And I'm pretty sure I've got a mistake in there. And this is where it's kind of handy to know the Excel function as well as the formula from the textbook. Because the Excel function is dramatically easier. You don't have to worry about all these parentheses. You don't have to worry about controlling for everything. I think if I add a parenthesis here and if I add another parenthesis here, I think it'll work. Let's press enter and see what we get. Well, that's a lot more reasonable number. And I show you that, and I went through it quickly because I wanted to demonstrate to you mostly the difficulty of entering this formula correctly. And it's just a formula pulled from the book. The Excel function, on the other hand, is just the future value function. And we start off with our rate, which is our 8% divided by 12, and that gives us our monthly interest rate. We type a comma, and then the number of periods, which is just the 10 years we'll be investing, an asterisk to multiply by the 12 months in a year. Then a comma, and then we click on the payment. Now, Excel's going to look at this and imagine that you're making a monthly payment, so you have a negative amount of money going out of your checking account and into your investment account. So you're going to want to make that negative. So we'll make that a negative C2. And then after that, we have this PV and this type. So the type is what we use to set it to an ordinary annuity or an annuity due. Ordinary annuity is the default. So if we want to enter an ordinary annuity, we don't have to do anything. So we're just going to close the parentheses and we're going to press enter. And it turns out our formula was correct. We got the exact same thing, and that's awful handy. Now we have to enter a nice complicated formula for our annuity due. But what's really interesting is that the formula isn't that complicated once you have the formula for an ordinary annuity entered. It's just the result you got from an ordinary annuity multiplied by 1 plus I, 1 plus the interest rate. So we'll do an equal sign. We'll click on our result from the ordinary annuity, type an asterisk, and then an open parentheses and type 1 plus our interest rate. Now we can't just stop at 8%. We have to remember we're doing this monthly. So we have to divide it by our 12 months by clicking on cell C4. We'll close that and hit enter, and we have another number. And what I want you to notice as I format it here is that it's slightly different. It's about $500 larger. So here's the beauty of the Excel function. It's so much easier than entering the formula for the annuity due. We type an equal sign and then FV for future value. It's the exact same function. We just have to enter different arguments. The rate is, of course, our 8% divided by our 12 months that we're dealing with. So a slash to divide, and click on the 12 hiding out in C4, a comma, and the number of periods. So we're going to be doing this for 120 months. So that's going to be our 10 years multiplied by our 12 months per year. And then our payment is, again, the $416.67. Of course, we want to put a negative sign in front of that because of that whole cash flow thing we have to be conscious of when we're entering an Excel function. We type a comma, our PV, that's going to be the present value. We use that if we have a big lump sum to put in. So if you had 10 grand right now and you want to put 10 grand into an investment and then add $416 a month every year for the next 10 years, that's where you enter that $10,000. We're going to enter a 0 because we're not using it. And then we type a comma, and now, I'm not sure if you can see this, it may have popped off the screen. Excel is giving us a prompt, and we can actually select it, I think. We want a 1, which is the beginning of the period, or we can enter a 1 rather in this blank. And so it's a 0 or a 1 argument. 0 is the default, meaning the end of the period or an ordinary annuity, and 1 is the other option you can enter here and make it happen at the beginning of the period. We close that parenthesis, we hit enter, and we end up with, well, the same number we had before when we entered the annuity due formula. And this is one of those things that's kind of nice to know how to do it both ways. If you know how to do it both ways, you can try it out both ways and you can check your answers. So if you ever find yourself learning how to use a new formula in Excel, it's actually very valuable to have that formula like from a textbook, plug that in, do it by hand while you try to figure out what you've got to put into the Excel function to make it work. And that's one thing that I always try to do. Now, if we wanted to do discounting, right, we're going to switch over to this other column and we're going to do the exact same thing, but we're going to be discounting. So in this first column here, in column C, we were asking the question, what happens if I invest $416 a month every month for the next 10 years? And the answer is, depending if you're using an ordinary annuity or an annuity due, you either get $76,000 and some change or $76,000, almost $77,000. And that's all a function of, does the payment come to us at the beginning of a month or at the end of a month? Now in this next example, it's a little bit different. The best way to think about this is, instead of you paying $416 a month, someone is paying you $416 a month, and you're trying to find out what is the lump sum equivalent to that $416 a month payment that you would have coming into your pocket. So we're going to discount this ordinary annuity. Don't forget to hit that like button, and as always, if you've got a better way of doing this, show us in the comments.